Welcome to Mrs. Lee's Chemistry Academy, where no students are left behind. Today, we're going to talk about acid-base reaction. There are two parts to this, so we're going to talk about part one first. Tying that to the objective from College Board, the student can translate an observed chemical change into a balanced chemical equation and justify the choice of equation type in terms of utility for the given circumstances. Now let's review the Bronsted-Lowry definition of an acid. That an acid is a proton donor, capable of donating the hydrogen ion. So here we have hydrochloric acid, which is a strong acid. When put into water, it ionizes and donates the proton to the water to form hydronium ion, leaving behind chloride ion. Therefore, hydrochloric acid is an acid because it donates the hydrogen ion. Now, by the Bronsted-Lowry definition, a base is a proton acceptor. Sodium hydroxide, when ionizes in water, forming sodium ion and hydroxide ion. And it is a base because the hydroxide ion can accept the proton in water and be neutralized to form water molecule. When we talk about neutralization reaction, it's basically an acid added to a base to form a salt and water. And there are three kinds of this. The first one dealing with strong acid and strong base, such as hydrochloric acid and sodium hydroxide solution. When neutralized together, make sodium chloride salt dissolved in water and water molecule. So when we write the net ion equation, we will then cancel out the sodium and the chloride ions, which are spectator ions, leaving behind the H plus and the OH minus to form water molecule. The second category would be the weak acid neutralized by the strong base. For example, we have acetic acid neutralized by strong base barium hydroxide to form the ionic compound barium acetate that's soluble in water and water molecule as well. Now when we write the net ion equation, take care because the acetic acid is a weak acid which we do not ionize. However, we do ionize the strong base barium hydroxide. So we write the barium ion and the 2 hydroxide ion. Regarding the barium acetate, which is soluble compound, ionic, we separate into barium ion and 2 acetate ion. And the water remains intact as a molecule. So now we cancel out the barium ion, the spectator ion, and you have this net ionic equation. The third category is neutralization between a weak base and a strong acid, such as ammonia, the weak base, neutralized by the strong acid, hydrochloric acid, forming ammonium chloride. So the net ion equation, after canceling out the chloride spectator ion, you have NH3 plus H plus to form ammonium ion, NH4 plus. Solid magnesium hydroxide added to a solution of hydrobromic acid. So now let's practice writing it. For the solid, we do not dissociate it. So we write MgOH2 solid. And that we add hydrobromic acid HBr aqueous. And that forms magnesium bromide solution and water molecule. And we need to balance by putting 2 in front of HBr, the strong acid, and 2 in front of the water. Now let's ionize it. Now we cannot ionize the solid, so it stays together. But we can ionize or dissociate the strong acid, the hydrobromic acid, into hydrogen ion and bromide ion. Now that forms the soluble compound, magnesium ion and the bromide ion, 2 moles of that, and 2 water molecules. Now we can cancel out the spectator ion, which is the bromide ion, on both sides of the equation. And now you have the net ion equation. The next one, methylamine added to a solution of hydrochloric acid. Remembering methylamine, how you write this? CH3, NH2. Now this is a weak base. So we add that to a strong acid, HCl, hydrochloric, aqueous. We form this CH3 NH3Cl that's dissolved in water. Since methylamine is a weak base, we do not ionize it. We write it as like a molecule. But we do dissociate the strong acid, the hydrochloric acid, into H plus and Cl minus. And now this compound that's formed is ionic and is soluble in water. So we dissociate into ions. And now you cancel out the chloride, spectator ions. You have the net ionic equation. Try the next one. Ethanoic acid added to barium hydroxide. Ethanoic acid is a weak acid, HC2H3O2. Added to barium hydroxide, strong base, BaOH2. Solution, forming the barium acetate solution, proper formula, and water. Balanced by putting a 2 here and a 2 here. Now, when we write the net ionic equation, 2HC2H3O2, the weak acid stays together, but we dissociate the strong base into barium ion and hydroxide ion to form the soluble compound barium acetate ions and the water molecule. Now we cancel out the barium ion. And here you have the net ionic equation. The next problem, ammonia gas mixed with hydrogen chloride gas. Now, this is interesting because both of them are gases. So this is a weak base with a strong acid. Now, because there's no water environment, so you don't form ions. Therefore, you just write NH4Cl. Stay intact, okay? Next one, last one. Ammonia gas bubble into solution of ethanoic acid. This time we have a weak base bubble into a weak acid. So we have ammonia gas and acetic acid aqueous to form this ammonium and acetate ion. Now I take the liberty of jumping into the net ionic equation because I know ammonium acetate is water soluble. Nothing to be cancelled out. So here is the remaining net ionic equation. Now, the next one sums up my previous work. And you may want to pause your video so that you can follow the work and learn it more carefully. You may even want to practice writing them. Practice makes perfect. That's the only way to do this. Now, another one is gas formation. Salts of sulfide when react with acid forming hydrogen sulfide gas. So here is an example of sodium sulfide solution added to hydrochloric acid forming H2S, hydrogen sulfide gas, and the sodium chloride solution. Net ionic is just the hydrogen ion combining with the sulfide ion to make the gas. The next one is carbonate added to an acid to form CO2 gas, such as calcium carbonate added to 2 moles of hydrochloric acid forming calcium chloride and CO2 and H2O. Now, remember these Italian marbles, they are made out of calcium carbonate, and if they are placed outdoor in the garden, they look beautiful. But when there's acid rain, it's going to erode this beautiful statue and forming aqueous solution, calcium chloride, and then the gas is evolved into the air. So the net ionic is just hydrogen ion and calcium carbonate forming calcium ion and CO2 and water. The next one would be the salt of sulfite when added to acid generating SO2 gas, sulfur dioxide. So an example would be lithium sulfide and nitric acid forming lithium nitrate and sulfur dioxide gas and water. Net ionic is just hydrogen ion added to the sulfide ion making H2O, water, and SO2 gas. And the last one is ammonium salt added to a base will generate ammonia gas. And here the net ionic is ammonium ion and hydroxide ion forming ammonia and water. Now if you say that, oh, this is just way over me, this is way too much. Okay, don't worry about it. Just focus on equation number 2. That's the most popular one. That carbonate, when react with acid, will form CO2 and H2O. And don't worry too much about the others. Of course, it would be nice that you can learn it all, but if you can't, focus on number 2. Practice problem number 2. Excess nitric acid added to solid calcium carbonate. So we have HNO3 aqueous added to calcium carbonate, making calcium nitrate solution and H2O and CO2 gas. Remember, carbonic acid always dissociates into water and CO2, and then we multiply it by 2 here. So in the net ion equation, we have 2H plus, strong acid, and the 2 nitric ion, and the calcium carbonate solid to make calcium ion and 2 moles of nitric ion and water and CO2 gas. So we cancel out the nitric ion. So there you have your net ion equation. Solid strontium carbonate added to ethanoic acid. So we have strontium carbonate added to acetic acid. Ethanoic acid is same as acetic acid to form strontium acetate, the soluble compound, and water and CO2. Multiply this by 2 here. So the net ionic is that you cannot dissociate the strontium carbonate, but you can. You also don't dissociate the weak acid, but you do dissociate the soluble compound, the strontium ion, and the acetate ion, and water, and CO2. Nothing to cancel out. That's net ionic. Next one. Solid potassium carbonate added to sulfuric acid. So you have K2CO3 solid added to H2SO4 aqueous, forming K2SO4 aqueous potassium sulfate solution and water and CO2 gas. So we dissociate only the sulfuric acid, and we also dissociate the potassium sulfate. So now you can see the sulfate and sulfate will cancel out, and you have the net ionic equation, of course, with the K2CO3 and water and CO2. Concentrated hydrochloric acid added to solution of sodium sulfide, HCl aqueous, and sodium sulfide Na2S aqueous, forming sodium chloride soluble compound and hydrogen sulfide gas. So put a 2 here. So you would dissociate into 2H plus and 2 chloride ion for the strong acid. You would dissociate the sodium sulfide solution into ions. You would also, and I forgot to put a 2 here, so I would put 2 Na plus and 2 chloride ion and the gas H2S, and you cross out the spectator ion, the chloride ion. Oh, and the sodium ion as well, of course, that one too. Okay. Last one, hydrobromic acid. I'm just going to take the liberty of dissociating H and Br, strong acid. And we have potassium hydrogen carbonate, which is water soluble. So we have potassium ion and hydrogen carbonate ion. Now that forms potassium bromide, which is water soluble, and water and CO2 gas. Now we cancel out the potassium bromide. Now you have the net ion equation. So here's a recap of my previous work. If you find that I'm going fast, you may want to pause over here and write it down for practice. So to summarize what we've learned today in the lesson, we learned how to write net ion equation for acid-base neutralization reactions. And we also learned how to predict the type of gas formed by reacting the salts of sulfide, carbonate, and sulfite with H plus from the acid to form hydrogen sulfide, carbon dioxide, and sulfur dioxide gases, respectively. I hope that you have found the above lesson helpful to you. Any comments you have, we'd love to hear from you because they're extremely helpful to us. And I hope to see you again next time.